Hi, in this video we're going to talk about finding the titration. So we can use the formula of MAVA is equal to MBVB. Now this is molarity times volume of substance A is equal to molarity times volume of substance B. So for example, we have what volume of 0.1 molar NaOH is required to neutralize 25.00 ml of 0.110 hydrobromic acid. So we can use our easy formula of substance A. So let's say substance A is hydrobromic acid. We have 25 ml and a concentration of 0.01. So 0.110 times 0.02. And we can use milliliters over here. 25 milliliters, as long as we keep both of them milliliters. And now that is equal to molarity 0.100 times volume. And now we multiply these two together, we would finally get an answer of V is equal to 27.5 milliliters. Something to be aware of is if you meet a situation like BaOH2 where there's two OHs, make sure you do proper stoichiometry to get the correct answer. Like we talked about that in a few videos, but this is just another reminder. And our next problem. So this is our second question here. Now we have a solution of an acid of an unknown concentration, and then this is an indicator, and it changes color. It changes to pink when it's at a certain pH level. Now it said it is being titrated by this much of base. NaOH is a base. Now I asked you how many moles and the concentration. Okay, so M equals moles divided by liters. Let's first solve for base. Actually no, let's first solve for base, which means we have we're given 0.15 m is equal to moles divided by 0.0375 liters. That gives us a total of 0.0056 moles of OH minus, which is the base. The answer is the first 1/3 of the question. Now we need to calculate for the moles of H. So one thing you can do is do this, 0.0056 moles of OH minus. Now we are using hydroiodic acid, which is HI. So every 1 mole of H, there's 1 mole of OH. So that gives an answer of 0.0056 moles of H plus as well. Now finally, we're gonna use 0.0056 moles of H plus divided by the liters, which we're given was 0.02 liters, and that gives us an answer of 0.28 molars concentration of H plus, and that answers all 3 parts of the question. Now, or we can use our M1V1 formula, right? M1V1 equals M2V2. So let's say we have base first. We have 0.15 molar of times 37.5 ml is equal to 0.2. No, we're looking for the concentration. Is equal to M times 0. No, we can use milliliters over here, times 20 milliliters. And in the end, it will still get you a concentration of 0.28 molars of H plus. Now our second way to find titration is, let me first draw you a scenario over here, right? So you have this flask, and in the flask we have 100 milliliters of NaOH of an unknown concentration. And up here we're dropping in acid drop by drop. And up here we have H2SO4, and the concentration is 0.80 molars. Now, after you drop a certain amount, an indicator will change its color and tell you that the pH has changed already. So now you're solving for the unknown concentration, right? What you can do is use moles of what's in the beaker, NaOH, divided by the moles of what you're titrating it with, so our acid in this case, H2SO4. Multiply it by the milliliters of the acid, or what you're titrating with. In this case, it's the acid H2SO4, divided by the milliliters of the other thing, which is NaOH, of what is being titrated, NaOH. And finally, you multiply it by the molarity of what you're titrating it with. In this case, is the acid of H2SO4. And by using this formula, it will get you the concentration of the base. Concentration of what we're looking for. So let's plug the formula in. Alright, moles of NaOH, which is 2 moles, divided by 1 moles of H2SO4 times 8 ml of H2SO4. Oh, something else that we forgot to give with is that after 5.6 milliliters, it's completely fully titrated. So our ml will be 5.6 of H2SO4. That is a piece of information that I forgot to give you. And divide that by NaOH, which we start off with 100 ml. And finally, we multiply by the concentration of H2SO4. Our concentration of H2SO4 is given up here at 0.80 molars. And that will give us a final answer of 0.090 molars. And that is our concentration of NaOH. Now, this formula can be used for all kinds of titration problems, but what you got to make sure is where you put the acids and bases. If it's a base down here and you're solving for the concentration of the base, then this is the same formula you will use, except for NaOH, you're going to substitute base, and this will be acid, etc. But if it's swapped, like if the acid in here and you're dropping base into the acidic solution to titrate it, then the places of these acid and bases will switch as well. And also, this would only work if you're given the concentration of what you're titrating with, and when you're looking for the concentration of what is being titrated. And this is it. These are the 2 formulas that you can use to find the titration of a substance. Thank you for watching.